Hello friends, welcome to another video on prompting techniques. In this video, we are going to cover some of the advanced prompting techniques in continuation with my previous video where we have covered zero shot, few shot, one shot, chain of thought and tree of thought prompting techniques, right? This is the continuation for that. So our first prompting technique here is graph of thought prompting technique. If you remember my previous video in tree of thought, we were asking a model to look into various solutions, compare the trade-offs between them like pros, cons based on reliability, scalability and all those things, and then provide you a most recommended answer, right? Graph of thought does kind of similar approach, uses some kind of similar approach, but here the difference is here one solution or one factor may affect other solution and vice versa. So in tree of thought, all the solutions or the paths that were taken by the model were independent. They were not affecting each other. But in graph of thought prompting, problems like we use it for problems where solutions are more than one and one solution may affect other or vice versa. Maybe a factor on a solution may affect the solution another solution and vice versa. So where we have interconnected relations between the factors in the solution or solutions depend on each other, we use graph of thought prompting technique. So it is an advanced reasoning technique where the AI explores multiple interconnected ideas and allows reasoning paths to merge, loop, influence each other and revisits earlier conclusions when new information appears. So it's like unlike a chain or tree, a graph has nodes and connections in many directions, right? Like if you in the graph, nodes can be interdependent on each other, right? Same will apply here. So the core structure of a graph of thought prompting technique looks like this. Identify all the key factors which you can look like a node in a graph. Then explore how each factor influence others and update the reasoning when new constraint appears. Synthesize a final solution considering all interactions. So here as we are saying that we are asking the model to look into all the factors that will affect the solution, to look into how one factor influences other, and then based on the reasoning the model gets from this comparison, it tries to find a solution for you. So let's try a similar problem we have seen in the previous prompting techniques like chain of thought and tree of thought. A system design problem where I want to design a scalable payment system. Identify key factors such as scalability, security, latency and cost. Analyze how each factor affects the other. Revisits each decision if trade-offs appear and produce a final architecture. So I have already run this prompt on ChatGPT. So this is the same prompt. I have just copy pasted it from here to here, and you can see it's doing similar kind of thing. So it is looking into different factors that we have provided in our prompt: scalability, security, latency, and cost. As you can see, it's providing you about things about scalability, then security, latency, then cost, and it's calculating the trade-offs between them, how those factors interact, like how scalability and latency depend on each other, like more services, more network calls, high latency, and security versus latency, scalability versus cost, security versus cost, and all those things. After all this, it's now revisiting its earlier choices. So it was maybe internally it was thinking about initial native idea was big payment service with relational DB, right? So now it's not giving you it in detail. So earlier in the tree of thought and chain of thought prompting technique, you were getting every idea in detail, right? And then it was giving you a recommendation. So you were able to look into detail different solutions. Model was thinking internally and final recommendation from the model. So here model based on all these factors that are depending on each other, it is rejecting ideas internally which it does not want you to use. So second attempt is like full synchronous Marcus service and it's also rejecting that. Then final architecture, it's giving you the details about that, how it should look like and what you should do about it and all those things. So the difference here is about the intent. So in tree of thought and chain of thought, in chain of thought you basically look into a single solution. You take a straight path. You just ask the model to provide explanation about its thought process, right? Like how you reach to the solution and all. In tree of thought you do the same, but you move into multiple independent directions. Like you look, the model looks into multiple different solutions, independent solutions. Then it looks into the pros and cons of each other, gives you the recommendation based on that. But in graph of thought prompting technique, it based on the different factors that may affect your solution. It tries to generate a solution that will compliance with that. So it will not give you the solutions which are not scalable, reliable in this particular prompting case. It will just give you the solutions which will be most suitable according to the factors that you've asked the model to look into. So the another thing to notice here is that you may get the same answer, same recommendation in these prompting techniques. Like graph of thought and tree of thought may provide you the same exact recommendation, but the only difference is the way the model reaches to a solution. The way the model thinks about the problem, tries to solve it, differs based on the technique that you are using, and it applies to all the prompting techniques that we are going to discuss. Then another example is like career planning, where let's say I'm saying I want to choose a tech career, identify skills, market demand, learning time, long-term growth, analyze how these factors influence each other, adjust recommendations if constraints change, give a final decision. So I've run this prompt as well. This is the prompt, and here is the result. So here key factors to evaluate is skills required, market demand. So it's looking into these factors. Then it's comparing between them. I guess this is a huge table for different careers. What is required, what is not required, what is there, what is not there. For example, for software engineer, long-term growth is very high, learning time is medium, market demand is very high, skills required are high. For a UX designer, skills required are creative plus tech, market demand medium, learning time short, long-term growth is medium. So based on that, it will provide you uh, a tech career choice. So brief qualitative summary, it's providing you a summary. Then how factors interact with each other. It is giving you comparisons between all the factors that you have provided. Then according to the constraints, limited time and all those things, it will give you a solution. So decision framework, recommendations based on the general marketers. Yeah, this is the recommendation. So in the end, it's asking you to look into a career options of cloud plus DevOps engineer, because demand is globally and connects with modern architecture, pays well, can transition to security architecture and all those things. Then second best is software engineer, full stack. Then if you love data and math, then this. So based on the factors and based on the different how the factors are affecting different tech career choices, it's providing you the recommendations based on these, right? So the way the model is choosing a recommendation is different the way model choosing a recommendation in tree of thought or chain of thought. Final answer might be the same, but internal process is different for each prompting technique. So when do we need this graph of thought? Use GOT when problems have interdependent decisions. Obviously, when the problems have uh, interdependent decisions, like one decision might depend on another and vice versa. And new insights can change earlier assumptions. For example, for a particular tech, maybe the market changes, right? For example, right now the craze is about AI, so maybe AI jobs are more, but later point of time maybe the craze will not be that much, then jobs will go down, things like that, right? So new insights may change the assumptions and hence the solutions. Multiple dimensions affect each other. For example, for a tech career options, all these affect each other, right? Like skills required will lead to more market demand, less more market demand will lead to more jobs and all those things, right? So when the things depend on each other, graph of thought prompting is used in those kinds of problems. Some examples of such problems are system designs, policy decisions, product strategy, and research synthesis. obviously system designs, you cannot always say a one solution is the best one, right? I mean, it has so many components, and what component to use where and when is a very tough decision. You cannot like go on a straight path, right? You have to look into different things, and there multiple things also depend on each other. Like if you are using load balancer, what kind of load balancer, and then caching and all those things are there, right? Lots of components are there. So here this decisions is not straightforward, and graph of thought and tree of thought are the prompting techniques which works best here. Similarly, policy decisions, product strategy, research synthesis, all these kinds of areas are where this kind of prompting technique is best to use. Let's move to another one, which is self-consistency prompting technique. So in self-consistency prompting technique, a model kind of solves the problem multiple times. So as in tree of thought and graph of thought, basically graph of thought has an interdependent solution, and tree of thought model was generating multiple solutions, right? And after generating the solutions, it was comparing the solutions, like pros and cons for a solution, and then giving you a recommendation. And it was not a interdependent nodes, like it was like based trying to find out different solution for it, and then giving you the best one out of it. But in self consistency prompting technique, model acts as a multiple user, multiple independent people, you can say, where each person tries to solve the same problem in its own way and reaches to an answer independently, like without knowing what other person is doing or something like that. And at the end, whatever answer is most common will be your final answer. So here again, you might get the same answer for a particular problem as in GOT or TOT, but the way model approaches to the problem, the way model thinks about it and tries to solve it will differ. So here it solves the same problem multiple times, use different reasoning paths and compare the answers. And after that, it choose the most consistent one, the one that is in majority. It will give you that as a final answer. So here the intuition is like a thinking. Think of it like asking five smart people the same question. Each person tries to solve it in its own independent way. If four people independently reach the same answer, then that answer is more reliable. If all the answers differ, then obviously the problem is vague, or maybe some data is missing, or problem needs more clarity. The same is with this self-consistency prompting technique. Here, majority voting happens, and whichever answer gets the most of the votes wins. Basic structure of a self-consistency prompting technique will look something like this. Like solve the problem step by step, generate multiple independent solutions, compare the final answers, and return the most consistent answer. For example, for a simple math problem, it will be it will be something like this. I have already run this prompt as well for you. Let's go to the beginning. So this kind of prompt where we are asking it to solve a simple math problem, and we are asking it to generate three independent solutions and give us the most common one. So as you can see, it's a very simple problem, right? So here all the solutions look exactly same. Obviously it will be same. It's a factual problem, not a conceptual one, right? So we know that how to calculate the speed if the distance and time are given. So all of them will be using the same and hence reaching to the same answer. And it's now comparing all the results, and most all the results are same, so the final answer is 40. So for these kinds of problem, obviously this kind of prompting technique is not good, because you have facts here, right? You know what is the formula, this will never change, and then by using this formula the first answer is the correct one, right? You don't need to do it again and again, it will always be the same, right? So for these kinds of factual problems, all these kinds of prompting techniques are not good, like TOT, GOT. So you should avoid these in these scenarios. But when the problems are more complex and big, you can definitely go to them. For example, like recommending a backend technology for a beginner with JavaScript knowledge, generate three independent recommendations and compare them and choose the most consistent one. So here we have saying that a beginner knows some JavaScript, and then we want three different career option. We want a career option for him, and we are generating three independent recommendations. If you remember in the previous video, we have run similar kind of prompt for tree of thought, right? Where it provided three different full solutions, recommendations, then compared all of them and provided you Node.js as the answer. So here it will also again give you three independent recommendations, but it will not compare the trade-offs between them. That will be the difference. So recommendation 1 is Node.js and Next Plus. Recommendation 2 is Node.js and Nest.js. Recommendation 3 is Deno plus Fresh. But Node.js is coming multiple times, right? So as you can see, the final answer is Node.js plus X plus. I'm not sure how it took the X plus. Oh, from here it took this one actually, but yeah, it's recommending you this one as a final answer. So the only difference is it's not comparing trade-offs between them, right? So as you can see, each one is completely independent. Here is one recommendation, second recommendation, three recommendation. Like you are asking three different people. It's not comparing between them. If you remember in tree of thought, it was comparing the final output, right? Like why this is better, why this is not, and all those things. It will not look into that. It will just simply look the problem like you are entering the prompt three times to look into a career option, and each time you get an answer and you just pick the most consistent one. That's all. When you should use self-consistency prompting? When your accuracy matters more than the speed, because we are looking into the problem again and again, right? And more common the answer is, more accurate it may be. Problems involve reasoning or calculations, or you don't fully trust a single AI answer. When you don't fully trust a single AI answer, like chain of thought, in which you get a single answer, or like in zero shot, no shot, few shot prompting techniques, you get a single answer, right? Without any reasoning. If you don't trust that kind of answer, then you should go with this one. When preparing some educational or exam material, and avoid it when the questions are factual, like the mathematical problem. You need very fast responses and token users must be minimal. Obviously, because in these kinds of prompting techniques, tokens will be highly used. The answers are large, prompts may be big for complex problems and all those things. So token users will be more, the cost will be more, latency will be more. So if you want your answers to be small, crisp and short, then do not use these techniques. Here is a step-by-step comparison between tree of thought and self-consistency flow. It's an internal comparison. In tree of thought, it generates different approaches, explore each approach deeply, evaluates pros and cons, select the best reasoning path, and produce a final answer. So same thing, it will by looking into the answer given by the model, it looks similar to tree of thought, right? Where in tree of thought as well, it was providing you two different recommendations and finally giving you the one amongst them. But the internally model compares the trade-offs between them after generating the solutions, and comparing after evaluating the pros and cons only, it was giving you the final answer, right? One of them. But in self-consistency, it will generate those recommendations again and again independently. It will not evaluate pros and cons or compare the trade-offs of one solution over the other solution. It will just treat them as independent problem every time, and whatever the result is most common, it will just provide you as the final output. This is the internal difference between these prompting techniques. Same example, same problem, two techniques. So there is only single problem which Backend technology should a beginner learn. The way to write it in tree of thought prompt and self-consistency prompt is like this. In tree of thought prompting technique, you will say generate multiple backend options, analyze each for learning curve, demand and scalability, compare them and choose the best one. So what happens here? It will compare Node.js maybe versus Java versus Python, compare trade-offs, and then it will give you one intentionally. But in self-consistency, you will say something like this. Recommend a backend technology for a beginner, generate 5 independent recommendations, return the most consistent answer. So here what will happen? It will generate 5 independent recommendations. Let's say Node.js came 4 times, Java came a single time. So majority will win here. Node.js will win the this argument. Pros of self-consistency technique. It improves reliability without complex prompts. So it works with even simple prompts, right? Like in simple prompt as well, you can ask the model to run it again and again. So it will works with the simple prompt, and it's reliable because you are solving the problem more number of times, and you are going with the most common output. It's easy to add to the existing prompts because in this kind of prompting technique, you just need to add this line, solve this independently multiple times, and give the most consistent answer. This will just make any prompt a self-consistency prompt. It catches random reasoning errors because if one of the solution hallucinates, other might not. Because we are trying to use solve the same problem again and again, right? So if one of them, like let's say, gets stuck, others might not, and that will be voted out in the last voting, right? So it reduces hallucinations. Cons of self-consistency: it can reinforce the same wrong bias, but it can also happen that every time it took into a took some wrong info in consideration, right? Then every answer may not be correct, and it will confidently in the end will provide you the wrong answer because the voting is high for that. For example, let's just for some of the prompt, it's trying to solve the problem 5 times. Three of times it reached to a wrong conclusion. Two of the times it was correct. Then, but the final answer will be again the wrong because it is more common, right? So this could happen as well in this kind of technique. There is no deep trade-off analysis, like it doesn't compare solutions to each other, right? So there is no trade-off analysis here. TOT excels here. Token wastage without insight, because here you are trying to solve the problem again and again without any insight, right? In pre of thought, you were at least comparing the trade-offs, like you know why the one solution is better than other. There is nothing like this in this type of technique, right? There is no new insight. It's like you are inputting the same prompt again and again and generating solutions again and again from AI, and just choosing the most common manually, right? It's doing the same thing. So there is no new information or new insight while generating another solution. It just reads the prompt again based on the previous context, same context. It just tries to generate the solution and just gives you the most common one. And that is why it's not ideal for strategy and design patterns, because they require trade-offs. They need to, for these problems you need to know why one is better than other. So these kinds of problems should not be handled by self-consistency prompting technique. Now let's look into one more step back prompting technique. In this kind of prompting technique, you ask the AI to step back a little from a problem, think as into a look into a bigger picture, then generate some ideas, and using that generate the solution for the problem. So instead of diving into details immediately, the AI first asks what kind of problem it is. Like if it is a system design problem, then what are the core principles of the system design? Like what are the minimal things needed? If load balancer is being used, it is needed or not? If caching is needed or not? What is caching? What are different caching techniques? All the prior knowledge is needed, right, before reaching into the solution. So it's like that. Instead of directly jumping into the solution like all other previous techniques, it first gathers the knowledge. It finds out what all things are needed to solutionize this problem. Then it applies all those things to figure out a solution. So example, let's say you are finding the area of a circle, right? So direct prompt will be like this: find the area of a circle with radius 7. But step back prompting will say, first step back and identify the general formula to find the area of a circle, then use that formula to find the area of the circle with radius 7. So this is how step back prompting works. Let's look into a system design example. First, step back and explain general caching problem, and then apply those principles to design a caching strategy for a high traffic web application. Let's see this in ChatGPT. So I've put the same prompt here. So as you can see, first it's instead of directly giving a solution for this problem. Our problem is this, right? Not this one. Instead of directly moving to the solution, it's first trying to explain the general caching principles, like what is caching, how caching works, core caching dimensions, cache granularity, and everything it could think of, right? So as it is explaining all these things, Now it has context on a good context on caching, like what is caching, what are caching pros and cons, and how we should apply it, and all those things, right? Whatever it finds out, eviction strategies and all those things. Now it has context, full context on caching. After it has context on caching, it can apply those information in solving this problem. So now based on it, it's designing a cache strategy for a high traffic web application. So it is assuming, it's giving us the assumption that millions of daily users, read heavy workload, latency sensitive, and backed by a relational or NoSQL DB. So it's providing a solution step one, identify what to cache, maybe these things we need to cache, then typical layering, browser cache, CDN cache, then distributed cache, then database. So it's providing a layered cache solution and all these things. So here the difference is, instead of directly jumping into the solution, instead of directly giving you this as output, it first tries to understand what caching is, and then different caching strategies, and then provides you a solution based on that. So basically the context here increases for the model. It may provide you more accurate and more generic answer, more explainable things. So when you should use step back prompting, you should use a step back prompting when problems are conceptual or abstract. Obviously, for simple problems like this mathematical problem, this is not a great prompting technique. You just like write a single line, it will give you the same result. When you want clean explanations, you want to know how it reaches to the problem, what concepts it used to uh, give you the answer. Designing systems and strategies, it's great for that, because it will look into the system design first before providing you an architecture. It will look into different different components and how those components behave and everything. Teaching beginners how to think about a problem, you can use this prompting technique for that. And avoiding premature optimization, you should avoid it when things are mechanical, like when the tasks are already well defined, when you know what steps you need to exactly take to solve a problem, right? You don't need model to figure out different things on its own, right? Because you can just create a prompt, write all your instructions to it clearly, and model can do it for you. If the steps are already fixed and well defined, then you don't need to use these kinds of prompting techniques. You can just ask the model to follow all the steps one by one, and you can get your answer. When the speed matters more than insight, if you don't want to know everything about your answer, like if I'm using this particular load balancer, then you don't want to know what this load balancer does or how it is working. You don't want to know about this. You just want your answer as quickly as can, as the model can provide you the answer. Then you should avoid it, because in this particular technique, first model will give you model will gain the knowledge that may be required to solve the problem, right? So it may take, basically latency will be a little bit high. So if the speed matters and you want your answers more faster, then you should not use this technique. Pros are, again, it improves conceptual clarity, because it gives you a complete explanation about it. It reduces shallow and ad hoc answers, because before jumping to conclusion, it clears out the fundamental concepts and everything. So it that does not directly give you the answers, it just finds out details about it. It also works well with other techniques, because you can combine it with all the other techniques that you have seen so far. So you can just say something like this: step back a little, gather the information about this particular problem, maybe provided some resources, then explore. Like for the second part, you can use chain of thought and tree of thought prompting technique. Like step back a little and define all the caching strategies, then using that, explore different solutions that can be used to build a high traffic cache, and compare the trade-offs between them and provide the final recommendations. So basically it can be combined with other techniques. Cons are similar, like more latency, more cost, more tokens, more verbosity. The more lengthy answer will be, so more reading will be there. It will require good abstraction skills. For example, if model does not look into the correct knowledge. Like if it is looking into something wrong, then it will provide you the wrong answer, right? Like if in my previous video, if you remember, when I was um, in chain of thought or tree of thought, I was looking into the topic, right? uh, when I was trying to find the answer for topic q, it was providing me pub topic. It took topic as a pub topic, not as a uh, noun topic, right? It was providing me pub topic, it was providing me details about the queue and all. So if it is misunderstanding something, if the model is, if the prompt is vague or something like this, then it will look into wrong things that is required to solution, uh, so that is required to solve your problem, right? In that case, uh, you need to identify what principles it is using to solve your problem, if the principles it is using are correct or not. If not, then the solution is not correct, right? It will just suffer. So good abstraction skills are also needed to identify, to verify the solution here. It's not ideal for pure factual questions like mathematical and general knowledge and all those things. It's not required for these kinds of questions. Now, another prompting technique is ReAct prompting technique. ReAct prompting technique is a technique where the AI alternates between thinking and taking action and to solve a problem. It's basically right, we try to solve a problem step by step. Like we think about a problem, then act upon it, then again think about the problem, then again act upon it, and so on until unless we solutionize the whole thing. So similar approach is taken by the AI here. So here AI reasons first, decide what to do next, then act, perform an actions like call a tool, maybe search, calculate, query data, and then observe the result, then again reason again, then act again, then same thing happens again and again, uh, until the final answer is there. So core structure of a ReAct prompting is like this. First you provide a thought, like reason about this problem, then you provide an action, that perform an action, something like this, then observe, analyze the result, then decide the next step, and then give the final answer. So for example, let's say we are trying to solve this problem, what are the key features of HTTP2, then the ReAct prompting style will be thought, I need accurate up-to-date information, action will be like search for HTTP2 features, observation is like you already know about this multiplexing, header compression, server push and all, thought, summarize these clearly, and final answer. So here the model will first look into these multiplexing, header compression and all, then act based on that. So let's see this in action. I'll just go here. So in my first prompt I missed the problem statement, I just provided this thought. Let's try this one again. So let me copy it from here. Let's go down and let's remove this tick. Let's try it. So now it's providing you all the key features of the HTTP2, multiplexing, header compression, server push, and it's also providing you the one line summary. Because here you have provided an observation, right? Found multiplexing, header compression, and server push. So maybe it's providing you the answers based on that, whatever you have, whatever the observations you have provided here. So at the end, you want the model to summarize them clearly, right? So it's doing that. So this prompt is again a vague prompt. I have not written this prompt in a very big detail, but here model uses different tools to reason out the solution for you, and then you apply that to your problem. So for example, when you let's look into another example for teaching and YouTube creation, right? When you want to create a lesson on prompt engineering techniques, then thought is I want structured content, action is list known prompting techniques, then observation is like the techniques that you know the names of, or if you don't provide it, then it will just give you techniques based on its own recommendations. So the thought is deciding teaching order, structured lesson plan. So let's try this thing here. I'll just provide this and provide this, and I'll just remove the observation so that it doesn't only provide these 5. So let's try this. Let's remove the observation. So it's providing you a lesson structure at the end, like 0 shot, few shot, step by step, COT, TOT, GOT, ReAct. So introduction to prompt engineering, then core prompting techniques, 0 shot, few shot, step by step, chain of thought, tree of thought, graph of thought, ReAct prompting technique. It's providing you a comparison summary for that as well. So this is how ReAct prompting technique works. Basically, it all depends on your prompt. Like, it mainly works with the external data. In these prompts, we do not have any external data, right? So let's say you are providing some data, some docs, or uh, maybe Microsoft Excel to the model, right? That based on the data that is present in this Excel or in this document, choose your action for this problem, right? In that case, this type of prompting techniques are good. So here, this should be used when external data is required and tasks are multi-step and dynamic. Like, these kind of prompts are not very ideal for this prompting technique. Like, basically for these uh, other prompting techniques are better, like a chain of thought, tree of thought, and simple 0 shot, few shot. Like for this one, as you are asking about different types of engineering techniques, you can just go with the 0 shot, 1 shot, few shot. And for this HTTP to this is also a conceptual problem, right? You are asking about different concepts, right? So here, no external data is required, and your answer is not depend on something external data, something external feature, right? So this kind of prompting technique is not good for these kinds of prompts. So you should be using it when your answer depends on some data and which is not in your scope, so that if the data change, your action will change, right? Your reasoning will change. So these kinds of problems are used to solve these kinds of problems are solved by ReAct prompting technique. So tasks are multi-step and dynamic, which may change according to your data or some external factor. Accuracy matters more than speed at building AI agents and assistants. So it's this type of technique is usually used for building AI agents where the model needs to behave on the user input, right? So based on different inputs, model behaves differently, right? Like for these prompting techniques, the style the prompt is written, the way model approaches the problem will be different, right? So this kind of the building for building AI agents and assistants, this kind of prompting technique is used a lot because this uh, if you look into the from the model's perspective, models and model's behavior will change depending on the user input and the context provided to it, right? So it's depending on an external factor, which is the prompt given by the user or some data given by the user, right? So ReAct prompting technique is basically used best for problems like building AI agents and assistants. And obviously it is used where accuracy matters more than speed, because we want our model to provide more accurate answers, right? Rather than on speed, so it's used there. Avoid it when questions are purely conceptual, like these, like HTTP concepts and prompt engineering concept. They are like purely conceptual, right? So that's why you're not seeing much uh, difference in the answer than other techniques. It's all providing you the same things. No actions tools are needed, and you want very short answers. Obviously, when your answer does not need any action or tools and you want short answers, you should not use it. Same thing is happening here. Like, we don't need any tool to answer these, right? These are like general concept HTTP2 and prompt engineering techniques. So it's not good for these kinds of problems. Pros and cons are kind of similar. It reduces hallucinations by acting, searching, querying, like finding the data, reasoning it out, and then using it to solutionize the solution for you. Highly explainable, because you can see why an action was taken and how the final answer was evolved. Then it mimics the real human problem solving skill. Like, human first thinks about the problem, then act, then again think, then again act, things like that, right? So it mimics the same process. That is why it mimics the real human problem solving process. It is excellent for complex tasks like when the information is incomplete or conditions change mid-task. Like again, the agents, right, where a user can change the input. Like let's say first it's trying to do something, then it may ask the model to not do the same thing again and things like that, right? Where conditions may change, where the environment it may change in mid. This kind of prompting technique is better. Cons are again similar, like more tokens, more cost, more latency, slower, and overkill for simpler problems. It also requires tool integration because here model reasons out different depending on the different tools data, right? So if that it doesn't have any data, it doesn't have any tools to help it out, right? Then it cannot perform like a React prompting like a React prompt. Then so that is why it's harder to use in paid chat setups, like I have done that, right? There was no difference in the response, so we should not use it when the tools are not there to help the model. It can get stuck in the loops, like poorly designed prompts may repeat the actions of the model, so it may also over reason about the solution without concluding. So these are all the cons of React prompting. Now the next one is least to most prompting technique. In least to most prompting technique, you ask the AI to start with the simplest problem, then move move eventually to the more complex problem, and so on. So basically, here you divide your problem into different subtasks. You ask the model to solve the easiest one first, and then move to the more complex task to solve the whole problem. So the core structure here is something like this. Break the problem into simpler subproblems, solve the simplest one first, then use that result to solve the next level, and continue until the end to solve the full problem. Let's take into an example. Let's say we are designing a REST API. So we use least to most prompt for it, like design a REST API using least to most prompt steps. First, define what is REST API, then define this, then design request and response format, and finally consider error handling. So this prompt is really not good because information is incomplete. Basically, this is a vague prompt, right? What your REST API does, how much traffic will be there, and all those things are not here, right? Whether whether it is talking to some external microservice or it is using database or not, like we have provided nothing here. It's very vague prompt. So I've already run it for you. So as you can see, it is providing whatever we have written here, least to most prompt, in the least to prompt manner. It is defining what is REST API. It has just randomly pick a structure for a REST endpoint. It is defining that different operations for it. Then request response format it is defining. It has generated some random response for you because we have not provided anything to it, right? So then error handling and handle the codes we need to handle, details about them, response error responses, and various things about it, right? So least to most prompting technique is used when you can divide your problem into small sub problems and use the simple one first. Like in the REST API, the smallest one is like defining a REST endpoint structure, then error handling, then maybe other tasks like talking to other services and all. So those kinds of scenarios you can use this. Similarly, problems like system design, like designing a URL shortener. This is a classic high level design problem, right? Let's try this. Let's see the output for this one. So I have provided the problem, design a URL shortener, use the least to most prompt, design a URL shortener using least to most prompt reasoning. First explain the core functionality, then design basic data model, handle scalability and all those things. So as you can see, it's first deciding the core functionality, basic data model, then examples about it, API, this it's providing you an example about it, and then scalability, talking about the scalability, after that reliability and failure cases, and then in the end it will provide you a final mental model about the URL shortener. So it breaks the problems to different tasks. It talks about every task and then at the end will provide you a complete solution. We should use this kind of prompting technique when we are teaching beginners because it explains every step, right? It starts from the beginning basically. When the problem feels overwhelming and concepts depends on each other. in these kinds of scenarios, this kind of prompting technique is good. Explaining system designs or algorithms, creating educational YouTube content, and all those things. Avoid it when the task is already simple, you need fast answers, and problem cannot be decomposed easily. So it's similar, like for conceptual problems you should not use it, and if the problems cannot be broken down into simple tasks, then also you should not use it. For example, designing a URL shortener, you can divide the problem into simple tasks, right? Like first explain this, then do this, then do this, some things like that. If it is not possible, then you should not use this kind of prompting technique. Now there are many other prompting techniques as well. There are many more. Like if you will search into it, you will find 30 to 40 types, different names there out there. So I have explained few of them, like vaguely. I'm not going into the details of them. I'm just explain on a higher level on this, and I have provided you some reading material in description. I have provided you some links where you can find more prompting techniques, and you can learn about them by reading through them. So please go through them. So let's quickly talk about all three of them. So multi-agent prompting technique. Multi-agent prompting technique is where we use multiple AI agents instead of using single agent to solve our problem. Like for example, software development, we divide it into different tasks, and we use a separate agent to handle that task. For example, we have an architecture agent to design API structure. We have a developer agent to write code. We have a reviewer agent to review the code and for security and performance checks. We have a documentation agent to write documentation for us. So instead of relying on a single LLM model, we are using different models for different purposes. There may be different formats here as well. For example, you can use one LLM to provide you a solution, then you can use another LLM to review the solution, right? So basically, where you use multiple agents for different tasks, this comes under multi-agent prompting techniques. So final output is far stronger than the one agent alone, because here multiple agents are contributing to your solution, right? So it's obviously better than the single agent's answer. Then there is prompt chaining, where so it basically means providing the output of a prompt as an input to another prompt is called prompt chaining. So let's take into an example. Let's say you are generating ideas to create a YouTube video. So let's say the prompt one will be, give me 5 video ideas on prompt engineering for beginners. Then you get output. Then you use that output in the second prompt, that take idea 2 from the options given above and create a detailed outline. Then you give this outline in your third prompt, that convert this outline into a YouTube script and examples. So this is called prompt chaining. The last one is negative prompting. Negative prompting is a technique where you ask a model to avoid doing some things. For example, when you are trying to explain recursion for the beginners, you are saying model to not use any mathematical terms or advanced jargons, and to not include code. So where you are asking the model to stop doing things comes under the negative prompting. Okay, that is all for today's video. I hope you liked it, and please go through the reading material. Like these things will become more clear to you if you do some reading yourself. There are lots of other prompting techniques as well. And please like, share, and subscribe my channel. Thank you.